Hello. In this video, I want to go over SAT geometry problems. Now, when the SAT went digital recently, they did trim their geometry content way down. Some say that it's below 10%, but that's still going to leave you 5 or 6 geometry problems that you're going to need to know how to do. And before I go into them, I want to just remind you that when you have the SAT test in front of you, you will have at the beginning of each module this little page here that has some reference formulas such as area circle, especially the 30-60 and 45-45-90 right triangles. You really should know these ahead of time, so you shouldn't have to look at them, but they're there in case you need them. So just diving right in, I also want to ask you if you would hit the like and subscribe button, and don't forget to hit the notification bell, because as I add more and more SAT prep content, you're going to want to know as soon as I make a video, you can take a look at it and make sure you're helping yourself prepare for the SAT.
This problem says we have a right circular cylinder with a volume of 432 cubic centimeters. And they tell us the area of the base of the cylinder is 24 square centimeters, and they want the height. So just to review, when we have cylinders, that is the one that looks like a sort of a can. Okay, there's your cylinder, and then they talk about the bases are circles, and each circle base has a radius, right? So we need to know the formula. This is a formula they actually give you on the beginning of each section. And the formula is that the volume of a cylinder is equal to pi r squared h. Now we know the volume. They say the volume right there is 432. So I'm going to put in 432 equals, and then I don't have the radius. Okay, all I have is that the base of the cylinder, meaning the circle right in here, we know that area is 24, but I don't know the radius. So what you have to realize is that, remember that a circle, that circle's area is pi r squared. That is the area of a circle. So I don't actually need the radius. All I need to know is that this part, the pi r squared, the area of the base, that is 24. So I can substitute in for this pi r squared part. Again, I don't know what the radius is, but as long as I know that right there, I can plug in 24, and now all that's missing is the height. And then when you divide both sides by 24, then you realize that the height comes out to be the 18. So the answer is A. Here we are told that right triangle ABC has a hypotenuse of 54 and angle B is 30 degrees, and they want to know the value of tangent A. So this is a 30-60-90 geometry triangle problem. Again, so this is something they give you at the beginning of the section far as the 30-60-90 triangles. Okay, so again what it is you've got the triangle here and you've got the 30. And here's your hypotenuse. We're going to call this 2x, and the side opposite 30 is the x. And then the side opposite 60 is the x root 3. So applying that here, we know that we have 2x. We have the hypotenuse. So 54, this 54 is the 2x. So 2x is equal to 54. I can solve for that. Dividing by 2, I get x is equal to 27. Okay, that means that over here is a 27, and then over here is 27 square root of 3. Now, they want the tangent, so the tangent is, when we have the tangent, remember, tan is the opposite side over the adjacent side. So when I have that, be careful which angle they're talking about here, right? Because sometimes people will be careless and not, they'll do maybe the tangent of B instead of tangent of A. So we were talking about tangent of A, so it's the 27 square root of 3 over the 27. And then that comes out to be square root of 3. So another important formula we need to remember is the area of a triangle. So in this case, it's just area of a triangle is the base times the height divided by 2. So the base here is 5, so I'm going to have 5. The height is 3, so 5 times the 3 divided by 2 is 7.5. The area in this case is 7.5 square inches. Now this is a complicated problem here. It has a mixture of things you need to know. It says the radius of the circle P is 4 and central angle RPK is 60 degrees, and find the area of that yellow shaded sector area there. So jumping right in, you need to know that if the area of the circle is pi r squared, then we know that the area for this whole circle would be pi, and then since the radius is 4, we're going to have 4 squared, so really 16 pi. So the area here is 16 pi, and then from there, you've got to remember, so if we have 60 degrees, how many total degrees in a circle? 360. So if we have 60, if this, let's say we were going to have this whole sector here, this whole wedge, so if I had to draw a little picture here, and if I had this, if this is the R and this is P and K here, and then I wasn't dividing up into this little yellow part, but I just had this right in here, well, we know that this is 60 degrees. So 60 degrees, you need to do a ratio that the 60 degrees out of a total 360 degrees, right? Because 360 degrees would be all the way around. That means we have 1/6. This little pi piece in here is 1/6 of the circle. So that means that if I were to just find the area of this whole thing in here with basically this wedge taken out RPK, 1/6 of the area, which was 16 pi, then I'm going to have 16 pi over 6, which I can simplify right now at least to 8 pi over 3. So that would be the whole thing. However, they're talking about, no, I don't even want that. I don't want this triangle part in here. I want just the yellow area, which means I need to find the area of that triangle, and then I can subtract it. Okay, so finding the area of the triangle, if we've got a 30, 60, 90 triangle, which we do, okay, I'll draw it just the way it's drawn here, which is, we've got the P and then the R and then the K. And if this is 60 degrees right here, if I bring an altitude here, then this makes this a 30, and I got a 90 now here, and then that makes that a 60. I do know that the radius is 4, right? So the radius, say PK, that is 4. Using my 30, 60, 90 triangle, if the hypotenuse, because this is the hypotenuse right here, because it's across from this right angle, if the hypotenuse is 4, that means the side opposite 30, this part would be 2 from here to here. And then that would mean that this part across from the 60 is that 2, but then times the square root of 3. So what I've got is this RK, this whole, that's a base, that's 4. And then the height right here would be 2 square root of 3. So let me just draw that over here just to give a little bit more clarity on that. So again, I'm turning this upside down. Let me have a P here, an R, and a K. And if I have this now, this base is 4, and then I have this altitude here is 2 root 3, the area of the triangle being base times the height, which is 2 root 3, divided by 2, 8 root 3 divided by 2, 4 root 3. The area of this triangle, okay, what would be in here is 4 root 3. So if I'm taking the whole area of this whole region, subtracting just the triangle part in here, I would be left with the yellow part. So this one says in triangles ABC and DEF, angles B and E each have measures of 27 degrees. So let me just go ahead. You're going to want to sketch this right away. So I know that B and E have measures of 27. So I'm going to try to draw some acute angles here. I'll draw this down here. So let's say we have A, B, C. Now I don't think we know any more about it, like as it's isosceles or anything. No. So we know if I say that this is A, here is B, and then C, and I make B 27, it doesn't say, okay, and angles C and F each have 41. Alright, so that's a 41. Well, what do you know right now is that I could figure out the third angle, but let me just draw the other triangle first. Okay. So then this seems like it's pretty matching. I have D, and then I have an E, F, and then the angle for E is also 27, and then this angle down here, F, is the same as the 41 over there. So what is the question? It says, which additional piece of information is sufficient to determine whether triangle ABC is congruent? Okay, because right now, I can tell you, if you ever ask the question, we know they're similar. Okay, because they have, if two angles are congruent to two other angles in a different triangle, that's the AA similarity. We would know that they're similar, but they could be different sizes, just the same shape. Now, to know that they're exactly congruent, I'm going to need something else. There's a couple things you could do. So if you remember from way back in geometry, we had proving two triangles congruent was side, angle, side. Meaning, if you had two triangles and you knew that, if I knew that one side here and then this side was congruent to this side, if I had the included angles, then I would know that the triangle is congruent by side, angle, side. Those types of things. Well, what are the choices here? So if I could get these sides equal, that would work. So let me see if they say that. The measure of angle A. Now, so this isn't right when they say the measure of angle A. That's not enough, because just because they have the same angle measures, that again, they could be, you could have different sizes, right? I could draw ABC could be here, but then I could have a mini-me versions right here, the same shape, but the different size. That's not congruent. So what else have we got here? We've got that they say that the length of side AB, well, that's not going to work, because that's angle, side. That is not one of the choices. And then we've got lengths of sides BC and EF, and there it is. That's what I want. Okay, so if I have the included sides right here, that's angle, side, angle. Angle, side, angle, and that is one of the geometry proofs for proving triangles congruent. Here we have a right triangle with legs 24 centimeters and 21 centimeters. If the length of the triangle's hypotenuse, okay, so right now I know that I've got a right triangle, and I'm going to draw that with the legs. So the legs are the non-hypotenuse sides, right? I'll take this one, the 24. I'm not going to bother with the centimeters label, 21. Okay, if the length of the triangle's hypotenuse can be written in the form, okay, so right now we've got two of the three sides of a right triangle. Why don't we go ahead and do the Pythagorean theorem? So that's your a squared plus b squared is equal to c squared, where I can call this a here, I'll call that b. So what I want to be doing is doing a squared, so I'm going to go 21 squared, and then I'm going to do plus b is 24, so 24 squared, and that's going to equal c squared. So 21 squared is 441, plus when we have 24 squared, that's going to equal 576. That's equal to c squared. And then when I add in those two together, I get that this is 1017 is what is c squared. Now, if I want to take the square root of that, the square root of that isn't going to actually come out to be a very clean number, so we're going to have to be doing some simplifying. So, because I need to take the square root of the c squared and then the square root of 1017. But that comes out to be a decimal when I do it on a calculator. So let me see what else. What is a number? I need to be able to simplify the square root here. So I'd be trying numbers. Let me think. It's obviously can't be. So I need to factor this 1017 down. It's not an even number, so I'm not going to get 4 or 16 or any of those perfect squares to go into it. But I think I could just try, at least to start with, I could try I'm thinking of a 9. Start with some of the ones you're more familiar with. If I divide that by 9, I do get 113. So that's a 9, and that's a 113. So taking the square root of 9 and the square root of 113, so the square root of 9, we're going to get 3 coming out of the square root, and then I'm left with 113. So is there... Oh, and then that matches, okay, because see what happened is they said up here is that the hypotenuse can be written in the form 3 square root of d, where d is an integer. What is the value of d? Okay, so again, this is the hypotenuse. This is the 3 square root of 113, and they're saying, oh, we can write that as 3 squared of d. That's just a way of asking, hey, what would you get in the square root, under the square root sign? So that would be, the answer right there would be, I would put down, if I'm gridding this in, 113. Here's another triangle. This is not a right triangle. Oh, yes, it is. It's a hypotenuse. It's isosceles right triangle. Okay, so in this one, I'll draw my isosceles right triangle. So an isosceles right triangle, that's just a right triangle where the two legs are congruent to each other. By the way, that means that these two angles are also congruent, which means they're 45, 45. You need to know that. And this 45, 45 ratio, just like the 30, 60, 90 ratio, that is given to you at the beginning of the section. It shows you the ratios, but it's a really good idea to remember those going in. So in this case, we've got the isosceles right triangle has a hypotenuse of 58. So I'm going to put a 58 right in here. I'll put a 58 for the hypotenuse. What is the perimeter? Okay, so because I know this is a 45, 45, 90, okay, just to pull up to what you're going to be told either in the reference section at the beginning or just memorize the 45, 45, 90, is that when these are the same and then these two sides are the same, we call the hypotenuse, you can call this x root 2, and then this is x and x. Oop, this should be root 2, x root 2. Now, that means that in our model here, the 58 is equal to x root 2. So if I want to solve for x, I need to divide both sides of the equation by square root of 2. So I get a 58 divided by square root of 2. Probably want to simplify that, get that radical out of the bottom because it's a little bit complicated. We're going to add for the perimeter. So here I'm going to just multiply top and bottom by square root of 2. So that will simplify to, I've got a 58 square root of 2 over square root of 2 times square root of 2 is 2. Now I can do the 58 divided by the 2, and I get a 29 square root of 2. So that's each of these legs is 29 square root of 2 for both of them. And then they want the perimeter. So the perimeter, I'm going to be adding up. So we knew the hypotenuse there's 58. So I've got a 58, and then I have two of these, 29 root 2 and a 29 root 2. So adding square roots, I just get back to 29 of them and another 29 of them. I get 58 of them. 58 square roots of 2 I have a 58. And so that means that the answer for this one would be right here. So that's some geometry problems that you may see on there. Again, geometry is only about 10% of the test now, but that still comes out to be a decent number of points. You're still talking about maybe six geometry problems. Some of them can be kind of complicated. So make sure you're familiar with the formulas at the beginning of the section, especially the 30, 60, 90s, the 45, 45, 90s. Those are definitely going to be on there, so be ready for that.